Daniel, thanks for joining me on MedTech Unboxed.
Thanks for having me, Steve. Really looking forward to it.
Yeah, we've been talking about this, and everybody I think in MedTech knows the MicroLumen brand name and are very familiar with it. But in filmcast, polyimide PTFE, composites, and braid reinforcements. But there's so many other value-added capabilities that you have, and I'm pretty excited to go over some of those with you today.
Yeah, no, I appreciate you having us. I think polyimide has been our staple material for many years, and as the times have progressed, we've tried to bring in as many capabilities in-house, whether it's new materials or new processes or secondary assemblies and secondary operations to our tubes to just try to get as close as possible to that finished device. We've been finding more opportunities to do that with our tubing.
Yeah. Okay. But listening to your customers, right? I'm sure they've asked you to add these capabilities over the years.
Exactly. Yeah. I think we've, in good intention, we've always tried to stay away from saying no and just saying, give us the full drawing. We'll see what we can do, whether it's bringing in new secondary, machines, laminators, even swagers recently and crimping machines, things like that. So we try to bring it all in as much as we can.
Okay. Well, you sent me a nice box here.
Got a
box
damaged.
Yeah, perfectly packaged.
Perfect.
And it contained a tube with a bunch of samples, and I have them spread out on my desk. And I figured we'll just get right into them.
Yeah, definitely.
Okay.
Yeah. So let's see. I know we sent maybe like 10 different combinations of things, but feel free to throw them up and we'll see what we have.
Awesome. I'll go in order. The first one we're going to go through, Daniel, is the marker bands that are reflowed over P-backs, and it says it's braided polyimide tubing with P-backs reflowed over the marker bands. That's what we're looking at here.
So we can start with the shaft on that one. So that one is what we've been talking about. It's the PTFE composite, that PTFE polyimide blend. It's on the inner surface. Normally, that's a 1/4 thou to 1/2 thou in thickness, just as a surface finish, whether it's on the inside or on the outside. And then that's followed with some polyimide, a stainless steel braid. That one also has some axials for some torqueability, some column strength. And then we encapsulate all of that with polyimide. And that would be, a very normal shaft for us to make that we've been making for many years. Now, the addition is what you were pointing out there, those marker bands where, we're sourcing some platinum iridium marker bands, crimping them on, and then we're reflowing some P-backs over those marker bands here in-house as well, just creating a nice smooth edge for our customers and for the patient when it's being inserted into the body so that there's no sharp edges from both distal and proximal end of the band. Now, those will give you a nice little bump on the OD, which sometimes is not desired by our customers, so we can always then laser ablate some of that polyimide away to reduce the profile, and then now adding some more of those secondary processes in there to give a totally custom part.
Nice. Very nice. Okay, let's move. We got some pad printing capabilities as well, right, Daniel?
Yeah, so I think the pad printing is something we don't do in-house. We've been talking about bringing that in-house. We keep going back and forth on that, but we work with a lot of suppliers. I think what we do here is with all of our engineers, we're very knowledgeable about what our suppliers can do, and we try to use that knowledge to help our customers design, whether it's a pad print or a laser ablation, two things we still outsource. But kind of like you're feeling there, the diameter, the profile of that pad print is something that we're very familiar with, whether you have an OD constraint, do we need to work with our supplier on bringing that down? Do we want to laser ablate and pad print and do things like that? But I think we've worked with our suppliers where pad printing on polyimide is not the easiest. Sometimes it's a lot easier to do it on a thermoplastic, but we've done a lot of it with our suppliers as well.
Okay. Some pretty interesting. I think these get on the top end of your capabilities from an ID standpoint. 102 thou ID, PTFE braid or lined, braided with stainless steel, and then also braided with, I believe, nitinol, and then maybe a P-backs top layer, right? Is that what we're seeing here with these two?
Exactly, yeah. So those two parts are the exact same dimensions, the same pitch in terms of the braiding configuration. They're both manufactured with the same PTFE liner, which starts getting to the edge of the top of our capabilities. In development and in trial, we've gone as large as 160 thou. I don't know if that's something that we like to do right now, but definitely 100, 110 thou. We've done plenty of times within PTFE liners. We're starting to etch our PTFE in-house as well. So that's something that we're doing a lot of.
Nice.
And then for these particular parts, we have two totally different constructions where, you know, the P-backs, or that more gray part, has a nitinol braid. And in that case, the customer really wanted something that if you were to kink or damage, because at these larger diameters and thin profiles, you're going to have a lot of, you know, the parts will be very fragile at this dimension. So if you kink one of those parts, I don't know how many I sent you, but if you kink one of those, you can tell, and I have one here. You can barely tell where that part was kinked because it takes that original shape of the part from that nitinol material that it's used to braid. So that was a very interesting design that we were working with the customer, where even though it kinks, it can take its original shape.
Right.
And then this polyimide one was, okay, well, let's make a part that's just not going to kink, right? With radial strength and things like that. So so that was a pretty cool project we worked on. I think we're still making both of them for the customer and working on some finished device or finished secondary operations on these, but very cool parts where they're the exact same dimension with totally different feels.
Okay, excellent. Yeah, so up to 160 thou ID. Yeah, that's getting up there with considering you need a wire probably, right?
Exactly. Yeah. So working with those wire suppliers as well and making sure we get, you know, good quality, but we've gotten some great materials from all of our suppliers as well to make that PTFE liner.
Okay.
Very nice.
Excellent. Now we have some nice value add here. Looks like we have maybe some distal curving here, right?
Yeah, so that was a pretty cool part that we worked on, and something that we've never done in the past. So as you know, polyimide is a thermoset. Once you melt that and once you set it to its circular shape, you're not going to remelt it or reshape it very well. So curving a braided polyimide tube was nice and challenging, and you know, definitely trying to figure out what fixturing and what tools we needed to bring in house so that it maintained that shape from any relaxation or changes over time or aging and things like that. So we learned a lot with this part, and we've added that to our list of things that we're open to doing. If it's a thermoplastic part with no polyimide, it's a lot easier for us to shape set and things like that. But this polyimide part, if you look at the distal end as well, we've laser ablated some of the polyimide on the end, and then we bonded a platinum iridium marker band as well. And then that sample, I don't know if that one has a P-back sleeve encapsulating the whole thing, but some of them we've been able to just glue with some UV adhesives or different adhesives there on the end to really, you know, bond that marker band to the end without adding too much of a profile as well.
Okay, very nice. Let's move on to some radiopacity. We have some tungsten loaded tips, markers, I guess, right?
Yep. So those parts are also showing some of our secondary operations. So that the base of the part is a braided PTFE line polyimide tube, something that, you know, we make very easily. You know, after that, we're then adding a marker band on the distal end, adding a full body P-back sleeve on the entire part to embed that marker band, and it's thick enough where, you know, that profile is you don't even produce a bump from that marker band. And then we're adding a thermoplastic that I think that's a 63D tip with 40% barium sulfate or tungsten in this case added to the part. So that's then joined to the thermoplastic body right there at the marker band, so that you have the marker band at the very end and then an extension of that radio-opaque feature onto the tip. So that's something that we've been adding as well. You know, playing with some of those extrusions with some radio-opaque loading is also a fun challenge and a fun experience. Yeah. So that's been something we've been perfecting here as well.
Okay, very nice. Now we have some green polyimide with blue P-backs tips.
Yeah, so for the polyimide, it's known as, you know, just the amber material out in the industry. But, you know, we can make green polyimide, we can make it black, you know, even slight tones of burgundy or crimson with some of the additives that we have in house. So green is a very popular one, whether it's marketing or whether it's, you know, different applications, you know, projects, segregation and different plants. When you have two of the same size, you know, it works really well. And then the blue tip as well. So that's a thermoplastic sleeve that's being adhere directly onto the polyimide. And because that polyimide is fully cured, it's sometimes difficult to adhere thermoplastics onto polyimide.
Yeah.
It doesn't have some of those tensile strengths that you may be looking into. The adhesion forces aren't there, so it can pop right off with very low strength. So we have some levers that we've worked with internally with our polyimide so that PBEX adheres nicely. And then in this case, we have an extension of that blue thermoplastic tip extending past the polyimide end that you can see a lot easier when it's green, because you know, under that blue, that light blue, you can see where it terminates, and then we can trim that to length, you know, very easily in that design.
Okay, that's very nice. Yeah, you're really gonna throw people off, Daniel. People, the amber, right? It's polyimide, it's amber. Now you have green. It's like, wait a minute.
Yeah, I thought polyimide was amber and natural, right? So yeah, we'll start throwing in some cool stuff, and the marketing folks, their eyes open nice and wide.
Yeah. All right, so we have some braided polyimide plus the 72D PBEX black, and there's some laser processing on the end.
Yeah, so that part is really cool in the sense of, you know, back to the first part that we talked about where it's a braided polyimide shaft, you know, polyimide liner, braid, polyimide. And now we're adding PBEX on the outside in our filmcast process, which now you can get a lot more efficiencies that way. But same concept, right? You know, how do you get that PBEX to adhere to the polyimide well so that part, you know, doesn't delaminate in some stretching or elongation processes. So we've done a lot of things internally to our polyimide for that PBEX, whether it's black, natural, or any material to really grab on. And then once we do that, once you're laser ablating that PBEX away, is how do you manufacture that in a way that the PBEX that doesn't wrinkle on you or doesn't have any defects because of the coating process when you're going and sending it into a laser process. So some learning experiences there as well. And in that case, the laser ablation is so small where what we're doing there is you can now add a marker band in there, reflow it, and now you have a nice consistent profile throughout the outer diameter. You can cut that off, and now it can work as you know, insertion into another device. Now you have a step down, so you know you can plug that into other areas, or you know, just leave it as is, extend it as a tip, or make that ablation longer and create some flexibility there at the end because it's a little bit thinner. So all different kind of things that we can do, but I mean, step one is making that tubing the right way so that it, you know, once you add those laser ablations, you don't get anything, any surprises after the, you know, 5 or 6 layers you've added in continuous way.
That makes sense. That laser ablation gives you a lot of flexibility there on the tip, right? Yeah.
Yeah, exactly. Yeah, little piece right there. So I mean, we can make that a little bit longer. You can add a thin layer of PBEX on there so you don't ablate it all the way, and you know, you just target those specific diameters. Yeah.
Excellent. Now we have, I think, maybe a little bit similar, but it's an ADA plus 72D. Wow, TecoFlex.
Yeah, so
what we got here.
Yeah, so the cool thing I wanted to highlight with this part is, you know, we do that PTFE liner. The braid is a, you know, 1.5 thou round wire, which gives it some of that flexibility as well. Extremely high pick. I think this goes up to 180 pick on the braid, so you know, very dense.
Yeah.
But what keeps this part soft, being that it's such a thick wall, is that the majority of that TecoFlex is ADA, which is a very soft material. But as many people who play with thermoplastics know, is, you know, that ADA is extremely tacky, you know, especially in the film coat process that we're building parts layer by layer. That material is going to want to stick to itself or stick to the equipment that we're manufacturing the tubing on. So what we're doing here is at the very end, the majority of this wall is ADA, and we're adding a very thin skim coat of 72D PBEX on the outside, just as a surface finish.
Gotcha.
And really now our inspectors are feeling this parts, and it's as flexible as an ADA tube, but it feels like a 72D PBEX. So putting this into a knot, and it just doesn't want to kink, right? Which is the exact thing that we're looking for. And then it's nice and smooth for anybody inspecting this part, right? Your parts aren't sticking to themselves, and you get the full function of the ADA, which is really nice. And then all of that is done in the exact same machine setup. So we don't have to do ADA first, then set up a 72D run or anything like that. It's all in the same film cast process.
That's very nice. You're right. There's no tack to this.
No, not at all. It's smooth. Yeah.
But also very flexible.
Yeah, so we've done a lot of similar things with P-backs. We'll do like a 25D P-backs and a skim of maybe 55 or 63D. You know, for P-backs, I would say, you know, we can get as low as 55 or maybe even like a 40D with Mobilize or something like that on the outside.
Wow.
And same thing with Tico. We've done some 93A with Mobilize that is on that limit of some of that tackiness on top of 80A.
Now that's interesting, Daniel. The low friction additives that are traditionally added to those soft polymers to reduce tack. We're all familiar with those in extrusion, but
Yep.
in a solution or a film cast process, you can do that as well.
Yeah, exactly. So all of the components and all of the compounds that we're purchasing are pretty much the same as what an extruder would purchase. We're just coming here internally and diluting that or making it into a solution so that we can use it in our film cast process. And then you're ending up pretty much with the same part, but much thinner layers, tighter tolerances, which is what's the benefit of that film cast process. We're starting to develop some processes now to be able to add some of those thermoplastic layers as a liner, and we're doing that internally as well. So we're developing some of those so we can have now you know, a quarter thou or half a thou thermoplastic liner. You might reinforce that and put a half a thou layer on top of that. So now you have a, you know, maybe 1.5 thou wall with a liner, a braid, and a top coat, and then sliding that over maybe other devices and reflowing it right in, so you can have very, you know, strategic areas of reinforcement, but now with that adhesion from the thermoplastic liner.
Yeah. You know, when we in catheter design, we say profile is king, right?
Yeah, exactly.
There's no other process beyond film cast that allows you to get such thin wall thicknesses, and you're stacking up so many features within a ultra thin wall. It's amazing.
Yeah, with the, you know, for some of the thermoplastics that are a little bit more viscous, it's you know, we can change or manipulate some of our recipes internally as well. But for polyimide and all of our thermoplastics, we tend to say that we build close to 2 to 3 tenths at a time. So that gives us that accuracy and that precision and the profile really that we want to at any moment.
Yeah. So you talked about the high end, I think, being like 160 thou, right? And now we have some tiny, if you want, you can share it, or I can share these. These are like 16 thou ID.
Yeah, I'll have to share some magnified pictures of those. Those. So I was sharing a video of this part recently of online, and you know, when you put the animation online, this part looks huge, and sometimes you forget how small these parts are. This is I believe this one is a 12 thou. So we make this in 2 different combinations. We make a 16 thou ID and we make a 12 thou ID. This, yeah, I think you're right. This one may be 16. It's about 2.25 thou wall. So talking about those extremely low profiles, right? It's a half a thou PTFE liner. I believe it's 1/2 by 2.5 braid, 120 pick, so extremely high.
Yeah.
And then it has a 72 DP backs finish. So, you know, 3/4 of a thou just to make sure that braid gets embedded. So the cool part about this part is on that end. So we laser blade the P-backs away on the distal end. We put a marker band in that pocket, and then we put a thermoplastic sleeve and tip to extend off the end, all within a 16 and a 12 thou design. So that OD of the shaft, I believe, is 22.5 thou OD, and that bump only goes up to 23.5 after it's all done. So you can barely feel that bump on the end. Yeah.
All right.
So our operators, needless to say, you know, they love making that part and crimping and chipping that part and making hundreds of them a week. But that's, I would say, in secondary processes, that's probably on the smaller range of what we've done. We try to tip a 6 thou by 9 thou PTFE line coil P-backs part. And we had some success. So always pushing the limits here as our customers, you know, they let us.
Wow, that's amazing. Miniaturization.
Yeah.
All right, so we have 2 more. We have this purple Vistamed nylon 12, right? With so it's a polyimide liner braided with nylon 12.
Yeah, and those are just to show kind of what we talked about before about some of those compounds that we can get from our suppliers, and then we can really, once it's the thermoplastic, we can add barium sulfate, we can add all kinds of additives, mobilize, or colorants, right? Because we're diluting it in our system, but the same way that an extruder would buy the compound, we can do the same thing. And, at that point we can make it however you want. And for us, it coats the same, right? There's no additional change in our process because it's natural compared to purple or barium sulfate. Really, it's all in the recipe to dilute it. And then from there we can coat anything. And then that purple is cool too, because I think that purple is, I think it's 1 thou thickness. You can really see how purple that part is. It doesn't have any streaks. It doesn't have any lines from the polyimide under it or anything like that. So that, it talks about the concentricity of some of the parts that we make, as well as we're even with colorants that, can be quite difficult to do that at thin walls.
Gotcha. Yeah. Very nice. Yeah. All these materials that you can put as a tile layer, for instance, on the outside, are all common reflow type materials that are compatible with balloons and other materials that you might add to it, a nylon P-back TPU.
Yeah, and then from there, like you mentioned, people will over mold them, or we can handle some of the over molding. Like I said, bonding some balloons on there or tipping them after that. Yep.
Okay. And then Daniel, the last one is blue tube, similar, but this is a polythene.
Yep. So just to highlight some of the TPUs that we do also. So we saw that TecoFlex part earlier. This polythene part is similar. Polythene is another fun material to play with here, but we've done some 75D, 55D polythene, I think some 65D as well. And then that one has a white pad print, right? So I think that white pad print is a lot easier to print on a part like that compared to some of the other polyimide parts. But same idea. I think we've pad printed this part with 4 different colors and had 5 different polythene color combinations as well, and all done within the same run and same parameters, where if you need blue, green, orange, and you're not sure what color it is, we can do all of 3 in line on the same setup by just changing out the color and the solution in our process pretty quickly.
Okay. Wow, this has been great, Daniel. Truly amazing broad range of capabilities, right? And like we said, profile is king, and it's so thin, and there's so many extra, laser ablation and the braid reinforcements, the marker bands. It's a lot. So really appreciate you going over this.
Yeah, no problem. We appreciate it. And I think, every day, like you said, our customers are pushing us to bring new things in, even hydrophilic coating or even FEP heat shrink one day. We're bringing all of that stuff in house. So we're doing our best to try to expand our capabilities.
Okay. Well, maybe we'll have to run this again in maybe six months, and we can talk about those other capabilities that you talked about.
We'll have 10 new bags ready for Steve.
All right. Sounds like a plan. Thanks a lot, Daniel.
Thank you, Steve. Appreciate it.